What's going on, guys? Welcome back to this video. Today we're going to discuss runtime detection and evasion. You might have heard about this subject before, especially if you are planning to learn how to bypass antivirus. So basically, AV evasion is part of this subject. But the thing is about runtime detection is that the techniques used to bypass runtime detection are kind of different from AV evasion. But when you are planning to bypass antiviruses, you may need to learn how to bypass runtime detection. First, let's talk about runtime detection. So when an application is executed in Windows operating system, the application itself makes two important actions. The first one is calling APIs. So it performs API calls. The other thing, it interacts with the .NET components in Windows operating systems. So that is what a typical executable app does in Windows operating system when it is executed. Now, the thing is, this is called runtime. Okay, and usually runtime happens in memory. Okay. Now, when we talk about runtime detection here, we want to find out what the application is doing when it is running in memory. This involves understanding the API calls and interactions with the .NET framework. So technically here in runtime detection, what happens when an application is executed, the runtime detection technique or interface will first scan the code. Now, this is happening when the application is executed, okay, in memory. It scans the application code and it looks at the strings of the app. It monitors the changes the app is committing to the system, such as maybe registry changes. This includes also file changes. So the runtime detection determines or tries to determine the behavior of the application. Now, based on all of the above, if it's found to be malicious, then the runtime detection will block the app. Now, basically here, it could be an executable file, it could be a Powershell script, it could be anything else that can be executed. It could be another script, any other script. So the main difference between runtime detection and AV is that AV scans the application on disk. Okay, while runtime detection scans the app when it is executed in memory. So runtime detection sometimes can be more effective than AV. The thing is, these days, modern antiviruses integrate runtime detection in their components. For example, let's talk about Windows Defender. So Windows Defender is the default AV in Windows operating systems. Windows Defender has what is called the AMSI. You may have heard this term before, and AMSI stands for, let's use a different color. So A for the anti-malware scan, and I for the interface. So AMSI is a runtime detection technique, right? It is employed not only by Windows Defender, by many anti-malware products. It could also be employed by Malwarebytes, one of the most popular anti-malwares out there. So AMSI is a scanning interface. invented by Microsoft and used by various antivirus products to scan the application in memory. Technically, it will scan the code, the strings, and monitor the changes in the app. And now let's find out when AMSI is triggered in Windows operating system. So when you open an app and is prompted to confirm whether you want to run this as administrator, AMSI is triggered. So it's triggered in user account control. When you run a PowerShell script, this will trigger the AMSI to run. When you run the Windows script host, additionally, when you run any JavaScript plus Visual Basic Script and Office VPA macros. So if your AV, your antivirus, is using AMSI, okay, in Windows operating system, it will kick in whenever you use one of these components in Windows operating system. From Microsoft, the official definition of an AMSI is this: the Windows Anti-Malware Scan Interface is a versatile interface standard that allows your applications and services to integrate with any anti-malware product, okay, that's present on the machine. So this means that even if you don't have Windows Defender, okay, your other AV solution might still be integrating AMSI into its components and the various components in the operating system to perform the scanning. AMSI provides enhanced malware protection for your end users and their data, applications, and workloads. So having discussed the runtime detection and evasion, and the AMSI, now let's talk about how to evade this measure. So basically, let's assume that you might want to use an Excel document as your payload, right? You may want to use a PowerShell script and deliver it to your target machine or target user. So in order to do that, you have to take into account that the end machine might be using, or there might be AMSI integrated in the operating system of the target machine. This means you have to take this into consideration while crafting your Office macro or PowerShell script. Okay, now let's assume now that you have created a PowerShell script. We're going to call it payload.ps1. Okay, now you have sent this PowerShell script to your target user. Okay, now what happened here is that the user opened the PowerShell script, and then you got a PowerShell session here. Okay, now the scenario might be more complicated. For example, you might have found a vulnerability in a web application, and then you got PowerShell access. The main idea here is we're going to assume that you have got PowerShell reverse shell on the target machine, okay, through maybe Excel documents, user access control, or a regular PowerShell payload. More importantly here is to understand that the stage of bypassing AMSI starts here, when you first get access to the machine. It could be a PowerShell session, it could be a CMD prompt, it doesn't matter. Now we're going to start to learn what are the common techniques used to bypass AMSI. The first method is PowerShell downgrade attacks. Thing is about PowerShell downgrade attacks is that they rely on security features being absent from specific versions of PowerShell. So, for example, we have PowerShell version 3 and we have PowerShell version 2. Now the thing is, all operating systems come with two versions installed, but version 2 will not be activated. You will use mainly PowerShell version 3. PowerShell version 3 contains security features. Now most of these security features will prevent script execution. In order to execute scripts, you have to bypass this policy. In Powershell version 2, there is no security features. So when we talk about Powershell downgrade attack, we talk about forcing the operating system to use Powershell version 2. So let's go back to the scenario where you've got a Powershell access here. In order to let the operating system use the Powershell version 2 to take advantage of the security features being not there, is that you have to execute a command to do so. So the command is PowerShell dash version 2. When you are successful executing this command, your operating system now will switch to version 2, and you will successfully bypass any anti-malware scanning interface present on the system. The next thing you want to do is to execute system commands, such as maybe invoking mimikatz and harvesting credentials. For example, this could be an example command. So here, as you can see, guys, we forced the operating system to downgrade to version 2, and then we used the flag dash command, and in the dash command we specified the command we want to invoke. In this case, it is invoking mimikatz script. This should be downloaded prior to executing Powershell version 2. So after you have compromised the machine, you will download mimikatz into the machine, and then you will perform the downgrade attack, simultaneously executing the mimikatz script. That's an example. You can easily prevent them using two methods. The first one of prevention is remove Powershell v2. We're going to need to remove the Powershell v2 engine from the OS. The other option is to deny access to Powershell v2. How? We're going to need to use what's called application block listing. You can Google more about these solutions to find out how to do it. But basically, these are the most common preventions to Powershell downgrade attack. Now, let's discuss the other bypass technique. Powershell reflection attack. So in Powershell reflection attack, we use a Powershell feature by invoking it from the prompt. So it is ref.assembly. Okay, and then we followed with the rest of the command. When we invoke this in a Powershell session, technically we are trying to interact with the components of the .NET assemblies. This might be very technical for some of the people who are watching this video, but Powershell reflection relies on interacting with .NET assemblies via this cmdlet. Why? Because the AMSI relies heavily on .NET assemblies. So when we try to interact with .NET assembly components, we try to manipulate the components of the AMSI that uses .NET assemblies. For example, AMSI uses AMSI utilities, and also uses another component under the .NET assemblies, which was system. Let me show it here on the command. It's going to be more easier. So basically here, look at this. System management, automation, AMSI utilities. This is part of the .NET assemblies. Powershell reflection, by invoking the Powershell reflection here, we allow ourselves to interact with the components of the .NET assemblies, among which is the AMSI utilities. So why we do that? We want to manipulate how AMSI works and disable it. So they came up with this one-liner. If you execute in a Powershell session, you will bypass AMSI. So basically here, let's take a look at this. First, we invoke the assembly. we'll call the reflection function. Okay. And then we use the get type. We want to collect information about the current settings of the AMSI utilities. And then here what we want to do, we use the get field found here. The get field will retrieve the specified fields here. Most importantly, we want to retrieve information about the AMSI initialized field. And then, as you can see here, guys, we forward here the field information to the set value. We set the AMSI initialized field to null true. When we do that, we technically bypass AMSI. All right. The third method is automated, which is the preferred method by many people who want to save time, including myself. Let's talk about the tools that we can use to automate AMSI bypass. The first tool is amsi.fail. Let's talk about this tool and let's go visit the link. So the description says amsi.fail generates obfuscated partial snippets that break or disable AMSI for the current process. The snippets are randomly selected from a small pool of techniques, variations, before being obfuscated. Every snippet is obfuscated at runtime request so that no generated output share the same signature. So all you have to do here is to generate, and now we get this and execute it directly in a partial session. The other tool was AMSI trigger. AMSI trigger is a bit different in that it is invoked from the command line. So this is AMSI trigger, and all you have to do is to download the tool, okay, and then use the flags. So here AMSI trigger will tell you what are the components of your partial script that need to be changed, okay, in order to bypass AMSI. All you have to do is to supply the command, the name of the tool, -i. The I here will take two types of input. The first one is the malicious or the partial script that you have created, or it could be a link to this script. -f takes a couple of values. So 3, as said here, will show the triggers in line with the code. 2 triggers with line numbers, and 1 only show the triggers. So triggers means it scans the partial script and tells you what are the components, the variable names, the values that might be considered malicious by AMSI. So you will go ahead, rely on the output and change them. Okay, now we're gonna use the lab material provided by this room to discuss the AMSI bypass techniques. This room is part of the red teaming track, and the room can be found under the host evasions. All right, now the first one is partial downgrade attack. So to perform partial downgrade attack, we want to downgrade the partial version to use version 2. So all you have to do is to execute a single command. This will bring up version 2 in this operating system. Now what to do next, it's up to you. But the syntax is this. After you specify version 2, you can then execute system commands however you like. Okay, now the other technique is partial reflection. Using this one-liner, gonna copy this one-liner and perform a partial reflection attack. Okay, so we got a problem because we have downgrade to partial version 2. We're gonna have to do this one more time on a new partial session. As you can see here. And lastly, we have to take a look at the tasks. So partial downgrade, you will get the flag once you execute it in a command prompt, CMD. So this is for partial downgrade attack. Let's do this using the CMD. So we're going to copy this and use CMD command prompt. So once you do that, you will get the challenge flag. And then for partial reflection, okay, we're going to execute this in the command prompt as well. So we're going to copy the one-liner. Okay, I'm gonna do this one more time. Yeah, so we're gonna have to do this using Powershell, looks like. So we already did this. I'm gonna execute this one more time. For the rest of the tasks, there are no specific questions to answer. So this would wrap this video up. Thank you guys for watching.